All right, good morning, everyone. This is Mrs. Rondo, and I'm going to be sharing a lesson on inscribed quadrilaterals. Our essential question: how do we use properties of circles to find missing values in quadrilaterals? And then our learning target, and yes, please make sure that we write this down. The learning target is I can prove properties of angles for quadrilaterals inscribed in a circle. You are going to need lots of color today, 4 different colors. And so here we go with our lesson. So we're going to be talking about properties of inscribed quadrilaterals, and you're going to put this right there in your notes. The first property is that the sum of the angles in a quadrilateral is 360 degrees. So we're going to go ahead and go through and mark our angles. I'm going to start with red, and I'm going to mark angle C with 1 arc mark. And we're going to mark each of these as different with different arc marks because we're not really sure if they are the same angle measure or not. It's possible, but it pretty much looks like they're all different angle measures. And without knowing, we're just going to mark them each with a different color and a different number of arc marks. So there we go. Angle D is purple. I'm going to shift over to blue and use that for angle A, and 3 arc marks here at angle A, 1, 2, and 3. And then finally at angle B, we're going to use green and do 4 arc marks, 1, 2, 3, and 4. All right, so if I took all of those angles and added them up, they would equal 360 degrees. That's the first property. The second property is that opposite angles are supplementary. So here's what we mean by opposite angles. Grab your red, and we're going to make a statement here. The measure of angle C in red, we're going to use our regular writing utensil plus, and then the opposite angle from C is actually angle A. So grab your blue and then the measure of angle A. So those 2 angles are opposite each other because they're across the quadrilateral, not next to each other like D and C, but C and A are opposite. Also, a quick thing here, reminder what it means when we say supplementary. That means we are adding up to 180 degrees, and I'll even make a note up here. And I do apologize. I know I just ran right into this. If you needed more time, of course, feel free to pause the video to write that down. Opposite angles are supplementary. Cool. All right. So the other pair, though, that's also true. We did C and A. We also have in purple here, we have the measure of angle D plus, get my regular writing utensil, plus, and then the opposite angle to D would be B. So measure of angle B. If I add those 2 up, whatever their measures are, they will equal 180 degrees as well. Make that a little cleaner. Okay, so there you go. Those are our 2 properties. The angles in a quadrilateral add up to 360, and opposite angles are supplementary or add up to 180. Let's go ahead and get started with some examples. Here goes. Find the measures of the requested arcs and angles for the circle shown here. All right, so we are asked for, I'm going to start with red. We're asked for angle PSR. PSR would be this angle right here, which happens to be opposite from angle Q. So I know that angle S and angle Q would have to add up to 180 because they are opposite angles and they are supplementary. So I'm going to take 180 and I'm going to subtract the angle I know, which is 50, and I get 130. So the measure of angle PSR is 130 degrees. Moving right along. I'm going to go to green. And now I'm looking at the measure of angle SPQ. So let's see, SPQ is this angle right up here. And that happens to be across from or opposite the 95 degrees. So once again, the same idea, those 2 angles together have to equal 180. So I'm going to do 180 minus the angle I know, and that's going to give me 85 degrees. So here we go, 85 degrees for the measure of angle SPQ. All right, then we have some questions about arcs. So I'm going to continue to go through my color list here. I'm going to go to blue. This one asks for the measure of arc PR. Remember, 2 letters. That means it's a minor arc. So P to R, I'm going to go the shortest path, which would be here, P to R. And I'm going to notice something here with P and R. If I kind of trace those points back, I see that they form an angle over at angle Q. So this angle right here at Q, which is 50 degrees. And we learned a special feature of inscribed angles, inscribed because that vertex is on Q. The inscribed angle is half the arc, or the arc is twice as big as the angle. So basically, I would take my 50 degrees and I would multiply it by 2 to get 100 degrees for my arc. So the inscribed angle is half the arc, or half as big as the arc. So this one gives me 100 degrees. All right, then our last one, we have 3 letters, which means it's either a semicircle or a major arc. So let's check it out. I'm going to do this one in purple. I need S, P, Q. All right, so I have S to P to Q. Okay. And once again, I'm going to really note those endpoints at S and Q. If I kind of trace them back to this point P, I can see that I have an inscribed angle because P is on the circle. And so, oh, I did that. I mean, that's great, but that's not going to help us out. That's the side we want. I got to do the other side. My apologies. Let's back up just a titch. I want to trace back the other way because I'm trying to find that arc. My apologies. All right. So I am trying to find the other arc. I'm sorry, the other angle. No, the arc. Excuse me. All the words getting mixed up here. Okay, so I want the arc SPQ. So I want to trace back away from it. So I'm going to trace back this way. My apologies here for that. And so I'm tracing away from the arc. There's the angle R, which still is inscribed, and that angle happens to be, with 4 arc marks squeezed in there, 95 degrees. And so I know the arc is half the angle. So I'm going to do the same kind of thing I did before. I'm going to take 2 times the angle, and that will give me my arc. So 2 times 95 is going to be, let's see, 190, I believe, which means it definitely is a major arc because it's more than 180 degrees. So 190 degrees, and there's our first set of examples, or example 1. All right, example 2. I'm going to keep moving through, practicing this skill. I'm going to go back to my red here. What is the measure of angle WZY? WZY is this angle right here. I see that it is opposite the given angle of 84 degrees, and I know that the 2 angles together have their opposite. Inside a quadrilateral, they must add up to 180. So I'm going to do 180 minus the angle I know, and that's going to give me, I believe, 96 degrees. So this one is 96 degrees. On to the next one. It says, given the measure of arc ZWX, let's see, ZWX, all the way around. That is 200 degrees. Find angle ZYX. So we're asked for this angle right here. And if we notice the Z and the X that were the endpoints of our arc, if we trace back to the point Y, we can see that that's an inscribed angle and the matching arc. And so the angle is half the arc. So I'm going to take that 200 and I'm going to divide it by 2. And that tells me my angle is half as much as the arc. So this is going to equal 100 degrees. All right, I'm going to switch over to blue. It says find the measure of angle ZWX, which is this angle right here. 1, 2, 3, take 3 arc marks. And since we happen to have already found the opposite angle, so if I look at the one I just marked in blue, the opposite angle is right over here. And we already know that. We just found it. It is 100 degrees. And so opposite angles are supplementary when we're talking about an inscribed quadrilateral. So opposite angles are supplementary. I can take 180 and subtract the angle I know, and that's going to give me 80 degrees, which is my answer. All right, nicely done. We have one more that we're going to look at here, our final one. And of course, we had to make it harder. So now we see some algebraic expressions, and we're going to jump right in here. All right, so we are asked for the angle WXY. So I'm going to go ahead and put that in red, WXY, which is this angle right up here, and it's labeled the 2x. So I'm going to actually trace over that. It's 2x. Okay, and that's the angle we want. If I look at that angle and I look across, I have angle Z and I don't have a measurement. So even though this is the angle I want, I may be leaving that alone for a minute and working with some other things. So other things I notice is over here, I have my 3x, which is opposite my 2x plus 30. So I did mark those in the same color. They are opposite each other, but they are different measurements. But if they are opposite, we know that they have to add up to 180. So actually, even though I did the same color, I'm so sorry, guys. I'm going to go back and erase this and do it in a different color for us. Let's do purple. So 1, 2, 3. So we have opposite angles. They add up to 180. Here's the reason I want them in different colors, because we're going to say opposite angles. So I'm going to say 3x, and then I'm going to use my regular writing utensil plus, and then my other angle, which is 2x plus 30. So I have my two angles here set up. Opposite angles, the 3x and the 2x plus 30, they have to add up to 180. Now, this is still not the angle that I'm interested in, but I'm going to see possibly here, if I'm able to solve for x, then I might be able to find that angle I want to know. So I'm going to take this other information to help me out. So here goes. I have 3x and 2x, this guy and this guy. If I put those together, I get 5x. So 2x or 3x plus 2x is 5x. I can combine those, combine like terms, and then I have just that plus 30, which is going to hang off the back here. And remember, my goal is basically to solve for x. So to get x by itself, I would do inverse operations or do the opposite. Here, that would be instead of plus 30, we're going to subtract 30. And I add those up, I get 5x plus 30 and minus 30 is 0. 180 minus 30 is 150. Then I have 5x equals 150. Divide both sides by 5 to get that x by itself, and I end up with 30. So x is 30 degrees. Did I finish my problem? No, it didn't ask me for x. It asked me for the angle measure. So I'm going to go back to my red here, and the angle measure I was given that is the 2x. So I really am trying to figure out what is 2x. So I'm going to plug in. I just found that x is 30 degrees. And so I get 60. So my actual answer here, and I'm going to do this measure of angle WXY. Sorry, even though I wrote all this, I'm just going to clean it up here, but that's basically the gist. I'm just going to rewrite it, so don't mind me. You can catch up, copy down, but that should be essentially it. So the measure of angle WXY equals 2x. They told us that. And then I'm going to plug in my 30, and I get 60 degrees. So the measure of angle WXY equals 60 degrees. And that finishes our notes. Thank you. And again, if you missed anything, feel free to pause it, rewatch it, and make sure to check out your assignment. Check Google Classroom. All right, that's it, guys.